Discrete Fourier transform. In this chapter, we'll discuss about computations in DFT. Reversal property of DFT. DFT of x of minus n is x of minus k. DFT results are always periodic, and therefore we can write x of minus k is equal to x of minus k plus n, where n is the period of input as well as output signal. This can be simplified to x of n minus k. So let's take one example. X of n is 1, 2, 3, 4. Find x of k. It's a 4-step procedure. First DFT ka formula, then matrix representation of DFT formula, then matrix substitution, matrix multiplication, and then final answer. Now we have to find P of n in terms of x of k. P of n is 1, 4, 3, 2. If you want to find P of k in terms of x of k, we have to write P of n in terms of x of n. So let's compare these two signal values. X of n is 1, 2, 3, 4. P of n is 1, 4, 3, 2. We can easily make out that first value is exactly same. 2, 3, 4 is appearing here 4, 3, 2. Exactly in reverse order. That means P of n is x of minus n. So by time reversal property of DFT, we can write P of k equal to x of minus k. X of k is already calculated. We can easily write P of k. First value as it is, and then the reverse order. The last value minus 2j will come at the second position. Then minus 2. Then minus 2 plus 2j. This is P of k. X of k is given. X of k is 1, 2, 3, 4. And now we have to find DFT of the following sequences. We want to find DFT of x of minus n. DFT of x of minus n is x of minus k. X of k is given 1, 2, 3, 4. First value will remain as it is. 2, 3, 4 will write in reverse order, that is 4, 3, 2. Next, symmetry property of DFT. If x of n is real valued sequence, then x of k is x star of minus k. Symmetry property of DFT is only for real valued sequence. The signal has to be a real sequence. No imaginary part, no complex part. This is a periodic result, therefore we can write x star of n minus k. Let's take one example on this. The first 5 values of 8-point DFT of a real valued sequence are given. Let's break this into subparts. Real valued sequence. 8 point. That means there are 8 values. That means capital N is 8. Real valued sequence. X of k 5 values are given. Remaining 3 values we can calculate by symmetry property of DFT. According to symmetry property, x of k equal to x star of minus k. That is x star of n minus k. And here n is 8. That means x of k equal to x star of 8 minus k. 4, 2, 3, 4, 5 values of x of k are given. We can easily calculate remaining values by evaluating this expression. We know that k is equal to 5. When k is 5, we get x star of 8 minus 5, that is 3. X star of 3. This is x of 3. Complex conjugate of this x of 3. Replace j by minus j. So 0.20 plus j will change to minus j, 0.18. To find this value of x of k at k equal to 6, 8 minus 6 is 2, x of 2 is 6.4, complex conjugate will remain same because it's a real valued sequence. Next value at k equal to 7, we get x of 7 equal to x star of 1, x of 1 complex conjugate x star of 1. If you see this result, we can compare these values with reference to this middle point. Remember that whenever signal is real valued sequence, then about this midpoint, both the side values are complex conjugate, plus j minus j. 6.4 as it is because it's a real valued sequence. Minus j plus j, complex conjugate. If you see real part, They are symmetric. Symmetric means same on both the sides. So we can draw this conclusion. If x of n is real valued sequence, then real part of x of k is symmetric. This is real part of x of k is symmetric about k equal to n by 2. In this example, capital N is 8, 8 by 2 is 4. So about this point, both the side values are complex conjugate. Real part is symmetric, means exactly same, and imaginary part is antisymmetric, that means opposite polarity. It perfectly works when signal is real valued sequence. X of n is 1, 2, 3, 4. We have to find x of k. We did this n number of times. We have to find DFT of xc of n and x of n. DFT of xc of n using x of k. Every discrete time signal we can write in terms of even part of the signal and odd part of the signal. This xc of n is always half of x of n plus x of minus n, and x of n is half of x of n minus x of minus n. If you add these two, we'll get original x of n. So to find this DFT of xc of n, first let's write xc of n in terms of x of n. That we get it from this expression. By applying scaling, linearity and time reversal property, we get xc of k equal to half of x of k plus x of minus k. We know x of k. We already done in A part of the question. We can substitute x of k, x of minus k, add them, divide by 2, you will get this xc of k. And this xc of k is real part of x of k. This is x of k. This real part is xc of k. But this is valid because original sequence is real valued sequence. And the same thing applies for odd part of the signal. We'll take this equation, subtract these values, divide by 2. This is the answer. This is same as imaginary part of x of k. So xc of k is real part of x of k and x of k is imaginary part of x of k, provided x of n is real valued sequence. Let's revise these properties. All the properties that we have done so far. The first one is linearity property. DFT of a time x1 of n plus b time x2 of n is a time x1 of k plus b time x2 of k. If inputs are added, DFT results are also added. Periodicity property. DFT of x of n is x of k, but if x of n is periodic, x of n equal to x of n plus n, that means x of n is periodic. Then DFT results are also periodic. This is by definition of periodicity. Time shift property. If the signal is shifted in time domain, DFT of x of n minus m is wn raised to m k x of k. Time frequency property. Wn raised to minus m n x of n is x of k minus n. Here x of k is shifted in frequency domain. Time reversal property. DFT of x of minus n is x of minus k. Symmetry property. If x of n is real valued sequence, then x of k is x star of minus k. Even signal property. X of n equal to x of minus n, so x of k equal to x of minus k, and x of n equal to negated x of minus n, then x of k is negated x of minus k.
Coursera is an online learning platform designed to provide high quality structured education in a flexible and accessible way. The platform offers academics and professional courses across science, technology, engineering, and management. Visit www.coursera.in. Midnight Masterclass is a YouTube channel, and we welcome you to Midnight Masterclass your late night destination for learning that is actually fun.
Thank you.